Hi, Assignment 3, Task 7, Evaluating the Suitability of Event-Driven Programming for Non-Graphical User Interfaces. This is to achieve criteria D1 and it's the final criteria of the unit. The word evaluate means to identify advantages and disadvantages of something and then make a reasoned judgment. In order to answer this question, we need to explain the alternative programming paradigms, describe the different non-GUI interfaces that are possible, and then explain how a user interacts with them, and identify finally and critically the relative advantages and disadvantages of using event-driven programming to respond to user and system interaction. So in order to do that, the first thing we need to understand, remember, is what the paradigms were. So you've got procedural programming and event-driven programming. Procedural programming is where you execute instructions in a fixed order and force the user or system to respond to them in that order. So the program is in charge, everything else does what it says. Event-driven programs, on the other hand, are flexible. They can respond to multiple user and system events in an unknown order, and they can handle that scenario. The final option is procedural program using polling. So if you need to get information from different places, this is another option to event-driven programming. So the CPU periodically checks each device or service to see if it needs attention. The closest analogy I can think of is like you are a football agent, and polling is like picking up 10 different phones every few seconds to see if you've got a call. Instead of being able to get them all on one phone, you've got to look at 10 or 100 different phones to see what's going on. You haven't got time to do anything because you're just looking at each of your phones. The problem with polling, obviously, is it takes a lot of CPU time to keep looking even when there's nothing being required for you to do, and the only way to reduce that overhead is to check less frequently, which means you're going to reduce your response time, so you're going to wait longer for something to happen. So in order to explain EDP, we need to look at the following things: events, event loops, trigger functions, and event handlers. We need to understand how user interaction takes place. So a trigger is any kind of external event to the currently executing process that cause a change in the normal flow of the program instructions. It can be caused by user interaction with an interface, as text via a keyboard, as mice clicks on a GUI control on the interface, pressing physical buttons on a control pad on a remote, pressing virtual buttons on a web-based mobile or tablet application. There can be system-generated events caused by hardware devices like printers or sensors, or software services like antivirus warning of a malicious file. So what do some non-graphical user interfaces look like? So this is a classic command line text interface. The command that's being entered here is dir/p. It's been done in a way that means you can do one instruction at a time. So this would be suitable for procedural programming. You can put a command in, it can do it in that order. Wait till the next one does that, wait till the next one does that. It doesn't need to be event driven. Another situation for a non-graphical user interface is an alarm system. You've got keyboards and sensors. So on here, this is the keypad, and it's got sensors like a shock sensor, a check if the to see if a window's been broken. It might have motion detectors to see if someone's moving. It might have detectors to see if a door's been open, and later on we'll also look at a intelligent car one. So we look at the text-based one in a bit more detail. As the commands are entered as text and processed one at a time, so procedural could be used for this. However, system-generated events occur in an unpredictable way, as caused by hardware devices external to the CPU, like printers or sensors, like software services like antivirus software or malicious files. Hence event-driven program is going to be required, as although the user input might be in a fixed predictable order, the system events, triggers, may not be. So that's one type of text-based command line interface and why you might use event-driven programming. You need to come up with your own examples. Another alternative is to look at a control system. So I'm going to look at two control systems. One relates to a house and one relates to a car. So in this case, I've got a house. I've got a keypad to set it up. So activate the alarm, turn the alarm off, set which ones are going to work. I've got various sensors, so I might have a shock sensors put on my windows to make sure that if they're broken, it warns me straight away. The alarm goes off, police get informed, whether my security companies get informed. I might have a movement detector set up, so downstairs in the ground floor in the hall or in the back passage, I can see if someone's there, and that would trigger an alarm. I might only use that at night when I'm upstairs. I might have a door sensor, so that if someone gets through this door when I'm not expecting it, or the back door, it's going to fire up alarm and deal with it. So how does that relate to event-driven programming, or not? So first of all, the system is set. You've got an alarm control system. You've got event loops listening. It's going to see if something's happened. So let's take the example of a shock sensor. It's going to check to see if there's a vibration. If there is, it's then going to activate the appropriate trigger function, event handler, to make the appropriate alarm go off, whether it might be a flashing light, whether it might be a physical sound going off, whatever it might be. It might be a message being sent to my mobile phone. The other option, it may be listening for a movement detector. So if someone's walking around the house in the middle of the night when they shouldn't be, it will set off an alarm then. And again, the appropriate trigger function would be fired and the loop would continue. So the event loop's listening. Depending on what happens, the appropriate trigger's fired and it goes round. And eventually I'm going to deactivate the system, in which case it's going to stop listening. So, would event-driven programming be suitable for a home alarm control system? Well, first of all, we need to consider where you put the sensors. You've got multiple sensors in multiple places. If someone burgles the house, they might first of all break the window, or I might have left the window open, so they might detect them via a movement sensor. What do I need to do about it? So it might be it sets off alarm, it might be it sets off lights, it might be it sends a text message. Does it need to respond to multiple triggers at the same time? Yes, because I might have broken in first, someone might be moving around in the house, it might be that they've opened the door. There's possibility of multiple ways of them getting in, and it needs to be able to handle all of those. So why does the alarm system need to use event-driven programming? Well, why does it need to use that rather than a procedural polling system? Well, can you imagine if you had to wait to get a response? So it didn't check only once every 5 minutes, so they've already got in, they've taken your stuff, and then it looks to see if the house has been broken into, or every 10 minutes. You need it to be checking frequently. You need it to be checking multiple different detectors to see where they're coming in to bring up appropriate alarms. You could do it with procedural polling systems. It would be slower. It would be do things in a fixed order, which would make it easier for someone to evade the security, get in and deactivate it before the alarm went off. It would be better to use event-driven because it could do things, all of them at the same time, pick up all of them and respond to all of them at the same time using different bits of program. It would also be better to use event-driven because you could add extra sensors in, add extra parts to it, configure them, and not write any extra code. It would know how to put an extra sensor on a window, no problem. An extra sensor on a door, no problem. With a procedural polling system, you'd have to write a whole lot of new code to handle that possibility in your menu. So now I'm going to look at an intelligent next generation car system. So this is the link down here where I've got this information from. You can play the videos, you can see what it does. So with these systems, you can basically overcome the limitations of a human being. So you might have sensors on the side here to detect movement if I try and swap lanes, whether it be going back into a lane or going out into a lane. I can have sensors to check me blind spot. to see if I have missed something coming up there or on this side here. I can have sensors in front to see if this car is slowing down in front of me and I'm going to crash into them. I can have sensors to see if I've effectively fallen asleep at the wheel, so the steering wheel isn't being moved or being held correctly. And an intelligent system can override the driver so to avoid mistakes. So it could be that it sets off an alarm, flashing light or something, or it vibrates to make me aware that there's something on the inside or there's something that I'm about to hit. It could be overrides me. It physically stops me going that way, or it stops me accelerating, and it manages the process. But look at this web link here. Run the bits to see what's possible. So these are the ones I suggest you look at: the Nissan Leaf's intelligent blind spot intervention, lane intervention, backup intervention, distance control, forward collision, or even e-pedal. And then talk about those and evaluate whether EDP would be suitable. So what things would it need to respond to? We've already discussed them. What hardware sensors would we need? We'd need motion detectors, wouldn't we? We'd need possibly detectors to pick up on light. How might it respond? We've got is it going to flashing light? Is it going to override me? Is it going to make a sound? Is it going to vibrate the steering wheel? What's it going to do? Does it need to respond to multiple triggers at the same time? Well, I don't know about you, but I would want it to. If I am accelerating and there's something in a blind spot, I want it to be able to control the steering, respond to the steering, and respond to that thing in the blind spot. I don't want it to do one at a time. Would I want it to use event-driven programming? Well, yes, because it can respond to multiple things at the same time in an unpredictable order. Instantly. I don't, with a procedural polling system, it's going to have to wait. So I've already steered, I'm already about to crash into something on the side, and it's too busy checking to see if there's something in front or there's something behind. I'd want to know instantly where the danger is. I wouldn't want to wait. Going back to this, you need to talk about at least a couple of alternatives in terms of procedural programming. The main bit of the article is about describing some different non-GUI interfaces and explaining how the user interacts with them and identifying the relative advantages and disadvantages of using EDP to respond to in those systems. So I've talked about 3. I'd like you to talk about at least 2 of them properly, but you've got to evaluate. You have to point out the strengths, the advantages, the weaknesses, the disadvantages, and then say why you think EDP is suitable for at least some non-GUI interfaces.